Yes, ma'am.
Okay, fine. So we were here. Already we had seen the preparation and the reaction. जो रिएक्शन है वो थोड़ी स्मॉल फॉन्ट्स में लिखी हुई है, तो थोड़ा समझने का कोशिश करना। नहीं समझ में आएगा तो मैं कुछ चीजें शेयर कर दूंगी, तो उसमें से देख के पढ़ लेना। हम 2-5 मिनट्स वेट करते हैं, ये जिन लोगों को ऐड होना है वो ऐड हो जाए, उसके बाद स्टार्ट करते हैं। So you can communicate to your friends that if they wish to join, they can join, or we will start in 2-3 minutes. Okay, shall we start? I think now no more will join. So I am sharing the presentation. So I think it is visible again. Okay, so what we will obtain is we will obtain the light green crystalline salt of FeSO4 NH4 whole twice SO4 6H2O, that is also known as Mohr's salt. Now we have added H2SO4. So why we have added the H2SO4 in this aqueous solution? So such type of questions can be asked, that why we have added the dilute sulfuric acid in the preparation of ferrous ammonium sulfate? So the answer is dilute sulfuric acid is typically added to the aqueous solution of Mohr salt for what? To prevent the hydrolysis of ferrous sulfate. सो फेरस सल्फेट का हाइड्रोलिसिस ना हो जाए इसके लिए हम डाइल्यूट सल्फ्यूरिक एसिड को ऐड करते हैं इन द प्रिपरेशन ऑफ फेरस एमोनियम सल्फेट. द अनदर टाइप ऑफ क्वेश्चन कैन बी आस्क्ड which kind of product will be obtained as a ferrous ammonium sulfate? So that will be light green crystalline salt will be obtained in the preparation of ferrous ammonium sulfate. Then after we have to discuss the result that already you have learned to calculate the theoretical yield, practical yield and percentage yield in the semester 1 also. So in the same way we have to calculate here the result of the preparation of ferrous ammonium sulfate. So that was very easy practical. Practical number 1, the preparation of ferrous ammonium sulfate. The reaction was already balanced, so there was no need to balance the reaction equation. So in the practical number 2, that is preparation of tris acetyl acetonato manganese 3 chelate. So in that the requirements are manganese 2 chloride tetrahydrate, sodium acetate trihydrate, acetyl acetone that is CH3, CO, CH2, CO, CH3. So we can make it write down like this also to understand it clearly. So this is acetyl acetone. Then potassium permanganate is added and acetone is taken as a solvent. So here is the general reaction which is written. Manganese chloride that is MnCl2 and tetrahydrate it is written, so 4H2O. In the presence of KMnO4 that is potassium permanganate and in the presence of acetyl acetone that is written as HAC and AC that is acetyl and again AC. So the reaction is shown over here. MnCl2 into 4H2O plus KMnO4 plus hydrated acetyl acetone. So what it gives is Mn, that is from here, and AC and AC. This is the complete redox reaction. First we need to write the reaction and then after we start balancing the reaction which is given in the book of standard 12 redox reaction. That is completely based on the cation and number of cations and anions that we have to balance it. Then the rest of the things which is obtained is H2O, HCl that we will obtain from here and here, that is HCl, and the KCl that is the potassium chloride, the salt again the another Cl that is written over here. So first we have to write down the complete reaction. Then after we need to balance the complete reaction. So here first MnCl2 into 4H2O. So 4H2O, the 4 is already balanced, but HCl. So here we need to put 7, that is 7 HCl. The another is we need to keep 5, 5 3s are 15. So here we need to keep 15. So in this balance the reaction equation. Now we will see the preparation, how tris acetyl nato manganese 3 chelate. So first we have acetyl acetone 9 ml. So in what we have to take? We have to take it in a beaker of aqueous solution of manganese 2 chloride tetrahydrate and sodium acetate. Then after what we have to do is we have to add this acetyl acetone, and in the resultant system we need to add 1% aqueous potassium permanganate solution. 1% that is based on the sample which is given to you that how much gram of sample is given. So if the given sample is 2 gram, so the calculation is based on the 2 gram of sample. In that we have to add 9 ml of acetyl acetone and 5 gram of sodium acetate trihydrate and 1% of potassium permanganate, means the solution will be prepared of 50 ml. Then what we have to do is we have to heat the solution at 60 degrees Celsius for 10 minutes. Then after the reaction mixture will be cooled, we have to filter the reaction mixture and then we have to recrystallize it with acetone. Similar way that we had seen in the first practical, we have to dry weigh and report the result. Now here we have seen that MnACAC whole thrice, that is acetyl acetone, is prepared. So this is prepared by the non-green technique. So sodium acetate is added. So why that sodium acetate is added? So sodium acetate is added to neutralize the reaction. What? To neutralize the reaction. So in each practical we have to see that the other substance which is added in the complete reaction, why it is added. So here the sodium acetate is added, that is to neutralize the reaction mixture. Now we can see MnO4, or here we can see that MnO4, here I have written as an oxidizing agent. So here we had taken that MnCl2 in which the potassium permanganate is taken with that KMnO4. So in that MnO4 is an oxidizing agent. So the highest oxidation state of Mn is +7. So here in KMnO4, when MnO4 minus is taken at that time, the Mn has +7 oxidizing state. So in the presence of excess of acetyl acetone, what happens is it reduces MnO4 minus to Mn+2. So what happens? It is reduces to Mn+2. This is the complete redox reaction which we need to learn and to balance it. And the excess amount of acetyl acetone to produce the Mn+3. So at the end, what we are getting is MnAC thrice. That is, the Mn is obtained in +3 state. So these are the main things which we need to learn in this preparation. So again, the result is to be obtained with the theoretical yield, practical yield, and the percentage yield. Number 3, practical number 3, that is preparation of potassium tris oxalatoferrate 3. Again in that, first of all, we need to see the requirements. So what kind of requirements are there? First, we need to take ferrous ammonium sulfate, oxalic acid, potassium oxalate, sulfuric acid, and ethyl alcohol, that is as a solvent. So again we can see here that is ferrous ammonium sulfate. And the another one we have to take is potassium oxalate. Here it is written the reaction preparation. So first we have to take ferrous ammonium sulfate in hot distilled water containing 4 normal H2SO4, that is 0.4 ml of H2SO4 is taken in the 500 ml of beaker. Then after, what we have to add is we have to add the oxalic acid solution, 10% oxalic acid solution, that is 100 ml, and we have to heat the solution with complete stirring. Then what happens? The precipitates will be settled down. When we will add the oxalic acid, the precipitates will obtain, and that precipitates will be settled down in the base, and then the upper solution will be decant. Then after we have to add the distilled water, and again the excess of the liquid can be decant. Then after we have to add the potassium oxalate, that is already written over here. In the presence of hot distilled water, first we have to dissolve the potassium oxalate in the hot distilled water to obtain the precipitates, again in the beaker. Then keep the beaker in the steam bath and add slowly the H2O2 peroxide, hydrogen peroxide, and stir continuously. Maintain the solution temperature of 40 degree. Then keep the beaker on the wire gauze and heat the solution to boiling to avoid the precipitates of ferric oxide. The precipitates of ferric oxide should not be obtained, so that for that we need to maintain the temperature of the solution. So that's why we are adding H2O2, that is hydrogen peroxide. Then after, what we have to do is we have to add oxalic acid solution, 10% oxalic acid solution, that is 5 ml. So from that oxalic acid solution we have to add rapidly, and 1 ml of oxalic acid we have to add drop by drop in that solution. Then we have to filter the solution. So which kind of crystals will be obtained? So bright green colored crystals will be obtained. Then after we have to cool the solution, and then for the recrystallization we have to use ethyl alcohol as a solvent, or in place of ethyl alcohol we can use the rectified spirit or the small quantity of acetone. The same way, then you have to report the result by theoretical yield, practical yield, and the percentage yield. So this is the main reaction. Now the balancing of the reaction is again the same, that you have to balance. Here it is written K3FeC2O4 3. So that is potassium tris oxalatoferrate 3. So from where the name comes is based on the name of the redox reaction, which is already we had learned in standard 12th. So each reaction consists the same type of preparation. So once you can go through that chapter, that is redox reaction, in which oxidation and reduction is already given, so that you can again calculate the balance the redox reaction. So the question can become, what is the molecular formula of potassium tris oxalatoferrate? So then you have to write K3FeC2O4 whole thrice 3H2O. Then what is the role of potassium oxalate? What is the role of H2O2 in the reaction? So such type of questions can be asked. Then here it is preparation number 4. That preparation is potassium tris oxalate chromate 3 trihydrate. And in the same way the preparation number 6 is there. So in this again K2Cr2O7, that is potassium dichromate. Again potassium oxalate monohydrate and oxalic acid dihydrate. So here it is written oxalic acid and potassium oxalate in the presence of water. What we will obtain is K3Cr C2O4 3H2O. The other byproducts are 6CO2 and H2O. So this 6, this 2, 7, these are all to balance the reaction. So in the procedure, what we have to do is make a solution of potassium oxalate monohydrate and oxalic acid dihydrate in water. To this solution, what we have to add is we have to add the potassium dichromate. This is in small portion with constant stirring. We need to add potassium dichromate with the constant stirring drop by preparing the solution. Or we can add this directly in the solid form also. But pinch wise we have to add the potassium dichromate. Then concentrate the solution nearly to dryness. On cooling, what we will obtain is green shiny crystal of potassium trisoxalate will be formed. Again, we need to filter that crystal and drying with the help of filter paper. So basically in all these preparations now, as you all have the online exams, already the timetable is given for internal online exam. So what we need to see is in which preparation, which kind of requirements are there, why, which, according to the molecular formula, what is the general name of that preparation, and if the general name is given, then what is the molecular formula of that preparation. If the main ingredients is added like potassium dichromate, potassium oxalate, monohydrate, oxalic acid is added, and in that if what kind of crystals we are obtaining, so we need to learn in each preparation which kind of color of the crystals we are obtaining. So here it is written that green shiny crystals of potassium trisoxalate chromium will be obtained. In the same way, now you can see here it is potassium dichromate, potassium oxalate, potassium monohydrate. So same way here also, only potassium oxalate is not there. Then oxalic acid and potassium dichromate is same. The one ethanol is added that is used as a solvent. So the name of the preparation is preparation of potassium cis diaquo bis oxalato chromate 3. So in this preparation, the general reaction is K2Cr2O7, again that is potassium dichromate. Then oxalic acid hydrated, that is H2C2O4 H2O 2H2O. So what it is obtained is K, that is potassium Cr C2O4 whole twice H2O2. The byproducts obtained is CO2 and the excess of water molecules. Then again we need to balance the reaction mechanism. Now in the preparation, what it is given is we need to take oxalic acid and potassium dichromate crystals in the dry mortar. So mortar and pestle is always there in the lab. Then we need to grind the mixture with the pestle till the powder will be obtained. The powder will be of orange powder because potassium dichromate is having color. Then moisten the china dish with the water and drain excess of water. And we have to introduce the mixture at the center of dish and to cover with the watch glass. The vigorous reaction, what that vigorous reaction will be do in the low heat, that reaction will evolve the carbon dioxide and water which is obtained here in the reaction. So the viscous liquid will be obtained, a dark colored viscous liquid will be obtained. Then without cooling the obtained thick liquid, that it should be poured into the 10 ml of methanol. That methanol is used as a solvent. If required, we can add 5 ml of ethanol more if the complete solidification is not achieved. So which kind of color will be obtained? Black crystals will be obtained that will be seen in the daylight, or deep purple that can be seen in the artificial light. That kind of crystals will be obtained. Then we have to weigh it and we have to report the result. So these are the few preparations which is there in your syllabus. Yes, you can ask the questions or you can write me an email if you have any doubts. So you can ask if you have any doubts. So exam timetable is already out, right? Internal exams. So this is my email ID and this is my phone number.
Ma'am, role of potassium oxalate in experiment 4.
Experiment 4. Yes.
Ma'am, role of potassium oxalate. What is the role of it?
Potassium.
Oxalate.
Yes, potassium oxalate is added in the potassium dichromate. That potassium oxalate is already that is monohydrate. So to complete balance and neutralize the reaction and to obtain the product. See here it is already written that K3CrC2O4. So that oxalate will be obtained in the product.
Okay, thank you, ma'am.
Okay, if you have any more doubts, you can ask me, or you can ask to Unnati ma'am also. She is going to take your another practicals, rest of the practicals, apart from these practicals that already you have there in your syllabus. Or you can write me on my mail. I will check it out and I will make you more clear about these doubts. And if you don't have any queries, then we can end the meeting.